In this part, we are going to render and position all elements of the game, and we will start with index.css. Here we specify CSS variables to reuse them and not to write the same colors twice in different styles. So first is text color and then action color that will be used for ball and lives. Let's make it red. Next we set scene styles, and here we only specify border. Here we using our CSS variable. Next we adding styles for block, stroke width, and then color of stroke. Next we add styles for pedal, and we only need to fill it with blue color. And ball, we are using a CSS variable here also. Level will be just a text in the left top corner. Here we specify font weight and also color, and we are using fill here because it will be a SVG text element, not paragraph. Life is a small red rectangle at the top right corner, and we only need to fill it with action color. Next we create a new file. It is ball.js, and this element will receive a few parameters. They are x, y, and radius. And x and y, it is the center of the ball. We receive these parameters and return SVG element circle. Let's add a class name to it. And specify center x and center y and side with radius. Next we are adding a paddle component. This component receives x, y, width and height, so it's basically a simple rectangle. X and y are coordinates of the left top corner. Here we need to specify class name. Next, we are going to create a file block.js that will render our block. Let's also import getRange util. And also we need to know what is the max density, so we import block max density from levels. And first we need to have array of colors for each density. As more dense, as less transparency. So if a block have density of 3, it means it doesn't have transparency, and a part in RGBA will be equal to 1. Here we are using template string and calculate value for alpha part. Next, we create component itself. It's very similar to paddle. Specify class name here, and fill, we take color from our colors and pass density as an index. Then x, y, width and height the same way as in paddle. That's it. Next, we create a file for level component, and this component displays text that placed at top left corner. It receives unit and level. Level is simply a number, and unit is some abstract size, and we make font size equal to unit, and we also use this unit to position element. So we make x equal to unit, and you can think of x in this case as left property for absolute element. And y is similar to top element, but here we are multiplied by 2 because for text element we start from the center of the text. Next we go to lives, and we are not bothering ourselves with making lives in the form of classic red hearts. In our games, lives displayed as rounded rectangles at the right top corner, because why not? We'll make our life much simpler this way. And it receives a lives, container width and unit. And container width we need to know because we will place them at right top corner, and we don't have things like right for absolute elements in SVG. We need to know particular position. So here we are using getRange to have an array of elements, and we are going over each live, set class name here, then we specify Rx. We can think about this like border radius, then height equal to unit, and we make width equal to unit multiplied by 2. Let's make y equal to unit, and x we need to calculate. So we take container width, subtract unit from it, and subtract width multiplied by index of element plus 1, and also we subtract unit divided by 2 multiplied by index. And don't forget to set key. Next we go to the scene component. We implemented all boring components and ready to put them together. But first let's import all we need. We will use reducer to manage state, but in this part we won't implement any actions or handlers. Then we need to import levels in order to access our first level, and we will need to convert this level to game state. Then we import all our stateless components. level, lives, block, paddle, ball, all this component. Next, we will write a function that will return an initial level. And every time the player gets to a new level, we will save the number to local storage so that next time the user opens the game, he can continue from the last level. And therefore, at the start, we'll check if there's a level number saved in local storage, and then we'll decide to return parsed or just 0. And of course, everybody can hack our game by opening developer console and typing local storage level equal to some number. We need to project positions and distances from game to the state. For example, position of ball, size of the block. And to do this, we write a function that receives container size and game size. Here we calculate width and height ratio, and unit on screen will be equal to minimum from these two. So our unit in the game is block width equal to unit of screen pixels. And then in order to project distance, we'll receive distance in the game units and simply multiplied by unit on screen. In similar way with project vector, we receive vector and scale byte by unit on screen. Next, we will write a function that will return initial state, and it receives container size, then it gets level by calling our function. After this, we can take game state. Here we are passing level by index. After this, we can get our projectors functions by calling get projectors, and we are passing container size that we receive this function and size of the game. Then we take all this nice stuff and return it. Includes level, game, container size, functions to project distances and vectors, time. It will be used to calculate duration between updates and then determine how far ball and pedal move during this period. Also, stop time. If it is not defined, it means that the user stops the game and we don't need to update the game state. And movement, it will be like left or right or undefined if user not moving pedal. And we'll have for now dummy reducer that receives state and return state. In once the next part we will finish it. Here we are using a user does a reducer hook. It receives reducer, then arguments that will be passed to get initial state function and get initial state function itself. Here we are taking all we need from the state. Then we calculate width of the view by using project distance. Now we have width in pixels after calling this function. Then our abstract unit for elements like level and lives. We will use just ball radius, so text will have size the same as radius of the ball. Next we return our SVG container. We specify width here. Then we calculate height. And of course class name. Then first we render level, and we need to pass unit here and also number of level. It will be level +1, so that user won't have level 0. Then we render lives. Here we simply pass a number of lives, width of container, therefore we moved this variable at the top, and unit. After this we are going over our blocks and render each of them. So we take density, we need to know position, and we also need to know width and height of the block. So we take everything we need and return our block component. Here we are passing density. We construct key for our block that represented by combination of X and Y of this block. To get width and height, we call in project distance. So we had distance in block width units, and now we have distance in pixels. And of course we need to pass X and Y, therefore we call project vector function and pass in position to it. When we are done with blocks, we can render our pedal. The same way we project distance for width and height. Super easy. Let's make it more clear here. And also we need to pass position, so we call project vector the same way as with the block. And the last element here is our ball. We need to project its center and we need to pass radius and to be equal to unit. So that's it. Let's run npm start and open it in the browser. So we can see that all elements are rendered and it is cool, but there is no action, no resize handlers. It will be in the next part.